Hey everyone, and welcome. Today we're putting on our detective hats. We're going to become statistical detectives, and our big mystery is this. How can you tell if a new idea is genuinely better, or if what you're seeing is just random luck? Our secret weapon for this investigation is a tool called ANOVA. So let's set the scene. Here's our case. A school district rolls out 3 brand new teaching methods. They're hoping one of them will be a game changer for math scores. At the end of the term, they collect all the test results. Now the big question is, did one method actually work better? Or are the little differences they see just, random chance? How can they possibly know for sure? You see, comparing just 2 things is one thing. But what happens when you have 3 groups, or 4, or even more? Suddenly, things get a whole lot trickier. You can't just eyeball it. You need a specialized tool for the job, and that's where our investigation really kicks off. And that special tool has a name, analysis of variance, or as we'll be calling it, ANOVA. Honestly, the easiest way to think about ANOVA is as a detective who specializes in these multi-group mysteries. Its whole job is to look at all the evidence and figure out one thing. Are the average results from all these groups basically the same? Or is there at least one that's a real standout? So how in the world does this detective actually work its magic? Well, the logic behind it is surprisingly slick and intuitive. So let's pull back the curtain and see how ANOVA sifts through the evidence to find the truth. And I promise, we'll do it without getting bogged down in a bunch of scary math. Now, like any good detective, ANOVA has a few ground rules it has to follow. Think of it as setting the scene correctly. First, the data in each group should kind of look like a bell curve. Second, the spread of the data within each group, how wide or skinny that bell is, needs to be pretty similar for all the groups. And finally, the samples have to be random. If those 3 conditions are met, our detective is ready to get to work. All right, now we get to the really cool part, the secret weapon in ANOVA's toolkit. It all boils down to this one powerful idea, the signal and the noise. If you can grasp this one concept, you'll understand the very heart of how ANOVA makes its call. So, ANOVA looks at variation in 2 different ways. First up is the signal. This is the difference we see between the average scores of our different teaching methods. Is there a big gap between how method 1 did on average and how method 3 did? That's our potential signal. But then there's the noise. This is just the natural, random variation of scores that happens within any single group. I mean, not every student using method 1 is going to get the exact same score, right? That variation is the background noise. So the million-dollar question is, how does our detective decide if that signal is strong enough to actually be heard over all that background noise? Well, it brilliantly combines them into a single, crucial piece of evidence. And this key piece of evidence is called the F-statistic. Really, it's just a simple ratio. You take the signal and you divide it by the noise. So if the difference between the groups is really large compared to the random variation within the groups, you're going to get a big F-statistic. And that is our clue. It's strong evidence that the groups really are different. Okay, theory is awesome, but let's get our hands dirty. Let's go back to our school district. Now that we understand the whole idea of signal, noise, and the F-statistic, we're ready to look at the actual evidence and solve this case. Here it is, the raw data straight from the case file. We've got 15 students with 5 in each of the 3 teaching methods. And you can see the scores are kind of all over the place. Our job is to figure out if there's a meaningful pattern hiding in here, or if it's just a bunch of random scatter. So the investigation follows 4 pretty logical steps. First, we measure the signal, that's the variation between the group averages. Second, we measure the noise, the variation within each group. Third, we calculate our key piece of evidence, that F-statistic, just by dividing the signal by the noise. And finally, we take that number and compare it to a statistical benchmark to get our verdict. And the lab results are in. After running all the numbers from our case file, our key piece of evidence emerges. The F-statistic for this case is 1.09. But what does that even mean? Is a 1.09 big enough to prove anything? To figure that out, we have to compare it to something. We compare our F value to a benchmark called the critical value. You can just think of this as the line in the sand. It's the hurdle our evidence has to clear to be considered significant. And in this case, that line is way up at 6.93. Our F value of 1.09, well, it doesn't even come close, does it? So, what's the verdict? The evidence just isn't strong enough. That potential signal is completely drowned out by all the random noise.
And what that means is we simply don't have enough proof to say that any of these teaching methods are actually different from each other. And here it is, the final verdict, straight from the pages of our source material. The conclusion is crystal clear. Based on this experiment, there is no statistical proof that any one teaching method is better than the others. The differences in scores we saw, it was probably just chance. Case closed. So we've solved the school district case, but why does this statistical detective, why does ANOVA actually matter beyond this one classroom example? Well, it's because the entire world is filled with noise and random variation, and ANOVA is this amazing tool that allows us to see past all that static. It lets scientists comparing different medical treatments, marketers testing out ad campaigns, or engineers testing new materials. It lets them find a real, meaningful signal. It helps us all make better decisions that are based on data, not just on a hunch. So the next time you see a headline or an ad or a study that claims some new product or diet is way better than all the others, you'll know the detective's secret. You can ask the most important question of all. Is the difference they found a real signal, or is it just getting lost in the noise?